Hello everyone. Today we are going to discuss the last topic of this chapter. So in the last class we have discussed about parallelograms. What are parallelograms? We have discussed its properties. So today we will be discussing some of the special types of parallelograms. Clear? So the first parallelogram is rhombus. So what is a rhombus? Let us see the definition. A rhombus is a quadrilateral with all sides of equal length. We know there are 4 sides, so all the sides will be of equal length. Now a rhombus has all the properties of a parallelogram and also that of a kite. We have learned about a parallelogram as well as we have learned about a kite. So how it satisfies the properties? Let us see. You can see this is a rhombus. First of all, let us see the definition that all the sides, this and this, all are of equal length. Clear? Now, it satisfies the properties of a parallelogram because in a parallelogram we have learned that the adjacent sides are equal. We have learned that the opposite sides are equal as well as parallel. You can see the opposite sides are parallel. The opposite angles are also equal here. As well as if we see the definition of a kite, the consecutive sides, or you can say the pair of consecutive sides, there are 2 pairs of consecutive sides, these and these and these and these, so that are also equal. So it satisfies the definition of a kite also. Clear? So a rhombus can be considered as a parallelogram also, and also it is a type of a kite also. Now moving on to the next parallelogram, that is, okay, before going to that, there is a property of a rhombus. So what is that property? The diagonals of a rhombus are perpendicular bisectors of each other. We already know in a parallelogram the diagonals bisect each other. This we know already. But they also bisect at 90 degrees. That is a perpendicular bisector. So let us see the diagram first. So this, if you have to prove this property, what you have to do is that let us consider, here we have to use congruency of triangles. Let us consider this triangle AOD and COD. This and this triangle. Now we know that since they bisect each other, since it is a parallelogram, rhombus is a type of a parallelogram. So these and this will be equal. That is OA and OC will be equal. OD is the common side, and since it is a rhombus, this side and this side, all the sides are of equal length. So AD will be equal to CD. So by SSS congruency, this triangle and this triangle are congruent. Now, so we will get by the corresponding parts of congruent triangles that this angle AOD and COD will be equal. Now we don't know what is the measurement. Now we know that angle AOD and angle COD forms a linear pair. So if it is a linear pair, it will be equal to 180 degree. There are some angle AOD and angle COD, the sum will be 180 degree. And since both are this equal, so if you substitute one on the other, we will get that this angle AOD will be also equal to angle COD, and that will be equal to what? 90 degree. This side also 90 degree and that side also is 90 degree. So therefore we get a linear pair. Clear? So the property of the rhombus is satisfied. They are perpendicular bisectors. Now next is the rectangle. So what is a rectangle? A rectangle is a parallelogram with equal angles. Yes. There is also a type of a parallelogram but with equal angles. Now the measure of each angle will be what? It will be 90 degree. How we got 90 degree? It is very simple. We know according to the angle sum property of a quadrilateral, the sum of all the 4 angles should be equal to 360 degree. Now since here all the 4 angles are equal, so if we divide 360 by 4, we get how much? We get 90 degree. So each of the angle will be 90 degree. That is a right angle. Now, being a parallelogram, since a rectangle is also a parallelogram, the rectangle has opposite sides of equal length and its diagonals bisect each other. You can see here, this opposite sides, this side and this side, and this side and this side are of equal length. And I have not drawn the these diagonals here, but if you draw the diagonals, they will bisect each other. Clear? Since it is a parallelogram. But then moving on, there is a property on these diagonals, that is, the diagonals of a rectangle are of equal length. If we have to prove this, how will we do that? I have taken two triangles here, this triangle ABD and triangle this ABD and ABC, this triangle and this triangle. So here we can use the congruency. This AB is common. This side and this side are equal, opposite sides of a rectangle, and this angle, this you can say BAD or DAB, whatever you say, and CBA, these are equal to 90 degree. Clear? So by SAS congruency, side angle side, these two triangles are equal, congruent. So by the corresponding parts of congruent triangles, this BD and this CA will be of equal length. So that's what we have to prove. The diagonals are of equal length. Clear? Now moving on to the last but not the least parallelogram, that is the square. So what is a square? A square is a rectangle with equal sides. It is a rectangle. Why I have called it a rectangle? We'll see that. A square has all the properties of a rectangle. That's why I have called it a rectangle. So it is a rectangle, but one added feature is there, that all the sides are equal. It is somewhat similar to rhombus, since rhombus is also all the sides equal, but rhombus is not a rectangle, but a square is a rectangle with all the sides equal. Now in a square, the diagonals bisect each other, since it is a type of a rectangle also. So all the length and also the length are equal and the perpendicular to each other. Not only it bisects or the lengths are equal, just like a rectangle, they are also perpendicular bisectors. Now this thing is somewhat similar to a rhombus. Now in rhombus also the diagonals are perpendicular bisectors. So now it gets confusing sometimes that while comparing these three types of parallelograms, they are always interrelated with each other. So don't get confused. They are always interrelated. Not the same thing, but they are interrelated. Now there is a last property given for a square, that the diagonals of a square are perpendicular bisectors. So if you have to prove that, what you have to note is that it is same like the rhombus proof that we have done that same thing. We'll consider this and this triangles, that is AOD and COD. Then by SSS congruency, that is OA will be equal to OC since they bisect each other. Then OD is the common side, and this AD will be equal to CD since all the sides are equal. So by SSS, that is side congruency, these two triangles AOD and triangle COD will be congruent. And since they are congruent, so obviously angle AOD and angle COD will be equal. But angle AOD and angle COD forms a linear pair. So the sum of these two angles will be equal to 180 degree. So each angle will be equal to 90 degrees since both are equal angles. So clear? In this way, we can prove the property of a square. So this chapter is over. So you can go through your textbook, you can solve the examples as well as you can solve these properties. It is clearly mentioned in your textbook. You can go through it. So I hope you all have understood this chapter. You can go through this whole chapter as well and see if you have any doubts. So that's it then. Thank you and have a nice day.